While NASA stayed silent, China altered the game. Between October 1st and 4th, 2025, China's Tianwen-1 probe orbiting Mars captured images of 3I-ATLAS, the interstellar visitor speeding through our solar system. One particular shot taken on October 3rd from nearly 29 million km away left scientists astounded. It displayed not only a luminous tail but a sprawling coma thousands of kilometers wide. What Tianwen-1 revealed was far more than a comet. It was a cosmic question no one yet has answered. The first glimpse, how Tianwen-1 caught the interstellar traveler. When the China National Space Administration announced the detection, the global astronomy community was shaken. The Tianwen-1 probe, quietly orbiting Mars since 2021, had never been designed for chasing deep space comets. It was a planetary surveyor intended to study Martian dunes and polar ice. Yet in early October 2025, it pivoted its high-resolution, high-risk camera away from Mars and toward an unknown visitor. 3I-ATLAS, only the third confirmed interstellar object ever observed. Capturing it was no simple task. 3I-ATLAS was faint, fast, and unpredictable. Tianwen-1 instruments were calibrated for bright surfaces, not dim objects drifting against a starry backdrop. Every exposure required precise timing, and engineers spent nights recalculating trajectories to ensure the camera could track an object moving tens of km/s. From October 1st to 4th, 2025, Tianwen-1 hunted the Wanderer across the Martian sky. On October 3rd, from roughly 28.96 million km away, success arrived. The probe captured the clearest view ever of 3I-ATLAS, a compact radiant nucleus enveloped by a coma stretching thousands of kilometers. Even through cosmic static, the symmetry seemed deliberate, almost sculpted. Beijing scientists called it a once-in-a-lifetime frame. To them, it wasn't just a comet. It was a fragment of another solar system, frozen in motion, drifting past Mars like a messenger from time itself. The data stunned mission planners. No other spacecraft had ever photographed an interstellar object so closely from another planet's orbit. China had achieved what no other nation, not even NASA, had. And the fact that these images emerged while NASA's own high-resolution files remained sealed only deepened the mystery. The camera that shouldn't have worked, HiRIC's impossible shot. HiRIC, short for High-Resolution Imaging Camera, was never designed to observe something like 3I-ATLAS. Engineered for bright Martian terrain, it mapped craters and dust storms, not fast-moving, faint interstellar objects. Yet, in the first week of October 2025, it captured what astronomers now call an impossible shot. 3I-ATLAS sped past Mars at over 68 km/s. Even a minor timing error could have rendered it invisible, a streak of nothingness across blackness. The camera team recalculated exposures constantly, adjusting for orbital drift, solar glare, and the comet's unpredictable brightness. HiRIC was pushed to its absolute limits. When the images returned, they astonished all. Against distant stars, a faint glowing figure emerged, sharp enough to reveal both the solid nucleus and the vast hazy coma. The brightness gradient indicated activity, material venting in real time through the solar wind. What seemed impossible was now undeniable. China's Mars probe had captured the first clear interstellar image from another planet's orbit. Behind the scenes, engineers admitted something odd. The exposure pattern had to shift mid-capture because 3I-ATLAS deviated slightly from predicted paths. A tiny drift, a fraction of a degree, suggested it might be propelled by forces beyond solar radiation or gas jets. The moving shadow, China's gift that stunned the world. A single still would have been historic, but China released more. Days after the Tianwen-1 announcement, CNSA released an animated GIF compiled from multiple frames. It showed 3I-ATLAS moving slowly across background stars, a faint blue-white glow shifting imperceptibly frame by frame. Short, grainy, silent, yet far more impactful than any NASA press release in months. The animation revealed motion, not passive drift. The coma shimmered as it rotated, brightness fluctuating in subtle patterns. The tail bent and pulsed, seemingly responding to invisible forces. Some credited solar wind, others saw a structured rhythm too deliberate to be random. The clip went viral within hours. Space enthusiasts called it the blink of another world. Scientists marveled that Tianwen-1 captured motion that even Hubble and Webb hadn't. Meanwhile, NASA stayed silent. Their high-resolution files from nearly the same time remained unreleased, giving the GIF an eerie power. Humanity was witnessing an object from another star system caught mid-flight, defying prediction. 3IATLAS's faint flicker wasn't just light, it was information whispering across the void. The strange glow inside the coma. Enhancing Tianwen-1 images, Chinese scientists discovered something unexpected. Surrounding the solid nucleus was a massive shimmering cloud, the coma spanning thousands of kilometers. Unlike normal cometary glows, it pulsed as if lit from within with subtle regular fluctuations too consistent to be camera noise. Normally, sunlight heats icy surfaces, releasing vapor and dust. But 3IATLAS's coma contained far less water, dominated by carbon dioxide with trace nickel and unknown metals. Its chemistry seemed optimized for resilience, surviving radiation, heat, and pressure that would destroy ordinary material. Brightness cycles within the halo behaved almost like a heartbeat, not matching the object's spin, implying localized emissions, not just reflected sunlight. NASA, still holding unreleased high-resolution images, offered no comment. Until then, China's data remained the only clear evidence. The impossible distance, capturing 3IATLAS from 29 million km away. At nearly 28.96 million km, about 75 times the Earth-Moon distance, even a tiny miscalculation could miss the target. HIRIC, designed for bright Martian surfaces, was repurposed for one of the boldest imaging attempts in history through manual corrections and long exposures. Tianwen-1 locked onto 3IATLAS traveling tens of km/s. Despite the distance, the images revealed the nucleus and detailed coma, proof of near-perfect stabilization and tracking. Scientists were intrigued why Tianwen-1 team targeted 3IATLAS at all. CNSA had quietly tracked it for months, ensuring they knew exactly when and where to look. Whether foresight, coincidence, or insider knowledge, humanity's clearest view came from Beijing, not NASA. Shifting the balance of discovery, the silence from NASA, why the US hasn't released its images. As China's images spread, Western excitement turned to frustration. NASA had its own spacecraft, the Mars Reconnaissance Orbiter, with the high-resolution imaging science experiment HiRISE, capable of 3 times Tianwen-1 resolution. Yet no images were released. Officially, a federal government shutdown before the comet's closest pass caused the delay. Scientists and the public remained skeptical. The orbiter had power, bandwidth, and instructions ready. Days turned to weeks and the silence grew suspicious. China processed and published images within days while the US stayed quiet. On October 31, 2025, Representative Ana Paulina Luna demanded the immediate release of 3IATLAS data, citing the public's right to information. The delay allowed China's achievement to dominate headlines, the political shockwave. By early November 2025, a scientific delay had become a political storm. The release of China's 3IATLAS images alongside NASA silence sparked the first space transparency crisis in decades. Lawmakers now demanded answers. Congresswoman Luna's October 31 letter accused NASA of withholding critical data, questioning whether the delay was truly due to a shutdown or something deliberate. The letter went viral. News outlets framed it as a rare challenge to NASA secrecy. Congressional aides confirmed private briefings with NASA officials who appeared uneasy about the images. Meanwhile, China continued releasing high-resolution stills, brightness readings, and spectrographic data, projecting confidence and control.